Hey everyone! Today we're going to talk about gravitation. You know, that invisible force that's basically the grand architect of our entire universe? It's what shapes everything, from something as simple as an apple falling from a tree all the way up to the orbits of galaxies.
So, let's kick things off with a huge puzzle, right? Isaac Newton told us that every single object in the universe is pulling on every other object. If that's true, then why isn't everything just a giant cosmic clump? Seriously, why don't the planets just smash into the sun, or the moon crash into us here on Earth?
Okay, to get to the bottom of that mystery, we've got to understand the rulebook, the fundamental rules of the game. And that brings us to one of the most famous laws in all of science, Newton's universal law of gravitation.
You've all heard the story about the apple, right? Well, that simple little moment led to this incredible realization. The exact same force that pulls an apple to the ground is what keeps the moon locked in orbit around the Earth. It's not two different things. It's one universal force that applies to everything, everywhere. Mind-blowing, really.
All right, don't let the math scare you off. This formula, it looks complicated, but it's actually the universe's secret recipe. It tells us two really simple but powerful things. First, see those two M's? That's mass. The more stuff something has, the stronger its pull. Easy enough. But here's the real kicker, that R squared on the bottom. That's for distance. And what it means is that distance doesn't just weaken gravity, it absolutely crushes it. If you double the distance between two things, the force drops to just 1/4 of what it was. And that is the secret sauce for why the universe isn't just one big cosmic blob.
Oh, and a quick but super important point here. We tend to use the words gravity and gravitation like they're the same thing. But for physicists, there's a little difference. Gravity is what we call Earth's specific pull, the thing that makes the apple fall. Gravitation, though, is the big picture, universal idea. The force between any two objects, anywhere in space. Okay, so how does all this get us back to our big question? If the sun is constantly tugging on the Earth, what keeps us from just spiraling in? Well, the answer is this beautifully delicate dance. A cosmic ballet, really. See, the secret to a stable orbit isn't just about one force. It's about a perfect balance, a cosmic tug of war between two things. I want you to picture swinging a ball on a string, right? The string is pulling the ball in the whole time. But the ball itself, it just wants to fly off in a straight line. It's that constant fight that creates the circle. And this is exactly what's happening in space. Gravitation is the centripetal force. That's just a fancy term for a center-seeking force. It's the string in our analogy, pulling the moon towards the Earth. Meanwhile, the moon's own forward momentum, its inertia, is what creates that feeling of an outward push. We often call that centrifugal force, but it's not really a force pulling out. It's just the moon trying to go straight, while gravity is constantly bending its path into an orbit. So when those two things are in perfect balance, bam, you get a stable orbit. The Earth is moving too fast to fall into the sun, but the sun's gravity is too strong for the Earth to just fly off into deep space. It's perfectly trapped in this constant, beautiful dance. So let's bring all this cosmic stuff back down to Earth, because these same rules have super practical effects that explain things we see every day, things we probably don't even think twice about. Let's check out a couple of them.
Okay, so here's a good one. Why do those massive trucks have such gigantic tires? I promise you, it's not a fashion statement. It all comes down to a key concept in physics called pressure.
So what is pressure? Well, it's not just about how much force you're using. It's about how concentrated that force is. Think about it. The same amount of push can have a totally different result depending on how big of an area you're pushing on.
And this is the perfect example of why a tiny little pin can poke through something your thumb can't. You might be pushing with the same force, but the pin focuses all that force onto one microscopic point, creating enormous pressure. A huge truck tire does the complete opposite. It takes all of that incredible weight and spreads it out over a really big area, lowering the pressure so it doesn't just sink into the road. Now, that force we just mentioned, the truck's push on the ground, that's what we call its weight. And this is a really important one, folks. Do not confuse weight with mass. They are not the same thing. Your mass is the amount of stuff you're made of. It's constant, no matter where you go in the universe. Your weight, on the other hand, is just the force of gravity pulling on your mass. That's why an astronaut weighs way less on the moon, even though they're still the same person. All right, for our last section, let's tackle something that seems like it should be the opposite of gravity: floating. It's kind of funny, but gravity's constant downward pull is actually the key to understanding why some things float. So think about this.
Why does an empty mug, if you push it underwater, pop right back up, but a solid metal ball just sinks like a rock? It's another one of those force battles. You've got gravity pulling the object down, of course, but at the same time, the water is pushing up on it. And that upward push has a name, the buoyant force.
And this explains how a gigantic ship made of thousands of tons of steel can float. I mean, it seems impossible, right? But it works because the ship's huge, hollow shape pushes a massive amount of water out of the way. The water pushes back up with a buoyant force equal to the weight of the water that was moved. And if that upward push is stronger than the ship's own weight pulling it down, well, it floats. That's Archimedes' principle in action.
So you see, it's all connected. From the mind-boggling dance of the planets in their orbits, down to why a truck needs big tires or why a ship floats on the ocean. It all comes back to these same fundamental rules. It's all governed by that universal, inescapable pull of gravitation.
So, the big takeaway here is that gravity really is the silent architect of our universe, and its rules play out on every single scale imaginable. Which, of course, leaves us with one final, big question to ponder. If gravity is the architect, what does that make the other fundamental forces? What are they building?